Welcome to this series on internal assessment. What I'm doing here is I'm trying to answer all these questions. If you go to the forum, you're going to see that there's heaps and heaps of questions. So if you go to IB Survival and you go down and look at what are the questions all about here. IA guide, failed results from my IA, Chemistry IA, what defines an IA. You can see that by far the biggest questions that students have are to do with internal assessment, and even if you go to the special website that only IB teachers have access to, you get the same thing. Even the teachers are asking IA. So what I've decided to do is show what I do for IAs. I'm just going to go to my Google Classroom and I'm going to just pull up the IAs from my students and just show you where I'm at. Now these resources here I'll make available on my website. I'll just put them there. I'll put the links to that in the description. And this template especially, IB doesn't like templates or checklists, but I have had this checked by a very experienced IB internal assessment examiner. We've gone through this and these are really the main things that you need to get, and I'll be working my way back to this quite often. So I'm going to put some anonymous reports out there. I'm hoping that all of you will watch it, and I'm talking to my students here. I'm putting them up anonymously. You're going to have to go and look at each other's and get good pointers from each other like I normally do in class. So this one's determining the dissolved oxygen using the Winkler method. Now the research here has been done quite extensively, but I want to see the chemical equations. Where are they? Here. That really belongs in the introduction. So get things in the right places. It's all about communication. They still count for marks. So put that in there. Now this is a data check. So let me just go to the data first. Where's the data? Alright, range of 5. Okay, good. For titrations you've got your raw data. So don't just give me this here like people often do. Don't just give me these values. Alright, not too bad. Alright, doing your titrations quite well, getting spot on, and this is the raw values. I've got to see these things. Okay, I would like to see the rough as well. Throw that in there. So here we've got an issue here, and my memory's not great, is it? But I know we discussed this. Alright, this again is discontinuous data. I know she was planning to go along the river, whichever river it was, and she was going to take samples as you go down, and obviously from the rainforest, the national park, down to Dunshea where it's really polluted. We're in a really good situation for that. The school's in a national park where there's little nice clean streams, and it goes down to the horrible Taipei City polluted water. So it's a really good transition. Now she had issues with just collecting that, and so she knows what the good, the really good design is, but she was only able to do that. So we're going to have to deal with that. Again, like the previous one, there will be some sort of marks lost, but you need to sort of minimize that. You can minimize that by using explanations and explaining and justifying what you've done. It's going to help, but there's no way you're going to get full marks for design. Okay, so we're done with the experiment, and the experiment's done quite well. The graph obviously needs to be fixed here with labels and units, and the stoichiometry seems to have been done quite well. I know they put a lot of effort into that. That needs to be referenced, otherwise the whole thing's plagiarism. You get 0. So get that cleaned up. I would number these two, put them in alphabetical order of the author. Thanks to Richard Thornley again. That was a nice video that helped her out a lot. And what else needs to be said? The independent variables are just massively lacking here. What time of day, what time of season was it? Pollution varies. different months of the year. I think winter's worse for depending on what you've got. If you've got a cold plant somewhere, it varies on the season. So our instruments, ranges, units, I need all that sort of stuff. Put that in there too. Okay, safety, I need this referenced. Where'd you get this information? Cleeps, don't know if I've spelled that wrong, might be 2 S's. Alright, that's the best place to go. Our school's got a subscription for that, so that's helpful because it's really clear on what to actually do with the safety. And just one other thing is you're not going to get full marks for data analysis, data collection, unless you've got observations. Now, I haven't said this in all of these videos, but I have asked everyone to take photos and videos of what they're doing, so we can easily go back to that if it's missed. And I think this, all of these experiments, especially with colours and stuff, are important because there's always weird things going on. So that's another thing that you can add to that. Apart from that, you're kind of very much on track. Even though you haven't done it and finished it all, you can also go forth and start to do your table of your error analysis. And that's about it. Oh, I would like to actually see the color changes too, so I can see that you're getting what you're meant to get, and I can compare it to what other people have got as far as the color changes in this titration reaction. Okay, and a photo of your of what you did and how you did it, so I can see what sort of equipment you were using. If you found that helpful, please like it and put some comments in the comments below, and please check out the other videos for more advice.